So, good afternoon, students. In this lecture, we are going to discuss tools and technologies for smart grid. So, in this second chapter, we are going to study what are the different tools and technologies which are useful for smart electric grid. Okay. Coming to introduction, so the classical optimization tools currently used can't handle the adaptability and statisticity of smart grid functions, and thus these competitive skills which are able to handle inadequate models of real world complexity is reduced, and solution method employed by the operator and decision making by operator is improved. So in this we are mainly going to discuss DS, that is decision support tools. There is a combining game theory and decision support system and analytical ideological processes used for computational. So DA includes many procedures, methods and tools for identifying clearly representing formal assessing the important assess of decision situation. So multi-criteria decision analysis is also taken into consideration, which involves in the numerous conflict evaluation. So DO support required two stages. The stage one evaluates the expected monetary value from the profit and loss data. Stage two is consider the possibilities of sampling and accurate information and evaluate the new EMV, and the outcomes of DA are not amenable to traditional statistical analysis. Particularly, we are using optimization techniques. So optimization techniques you already know, it consists of static and dynamic techniques for optimization. So in this we are performing linear programming, non-linear programming, mixed integer programming, dynamic programming. So they work better than the computer in conjunction with decision statistics tools. So computational tool techniques. We are going to use optimization techniques. So this is the what optimization cutting decision system in the DA, AHP, ANP, and this assessment will be there statistic and adaptive dynamic programming and evaluation program. After that, intelligence system, which includes expert systems, fuzzy logic system, artificial neural networks. So we discuss everything in brief in next presentations. So first, linear programming. Linear programming is widely used for mathematical modeling technique to determine the optimal location allocation of source resources among competitive devices. Resources typically include raw materials, manpower, machinery time, money and space. So it increases the manpower, resource will result in increase in the workload. So therefore the efficiency of the smart grid and increases. This is the linear programming. So in this, we consider the essential conditions are limited resources. So objective is to optimize, that is maximize the profit and minimize the cost. So linearity, increasing in the output. Homogeneity means so the machines to be identical. Divisibility means so it is a modification of linear programming called integer programming. So it is assumed that resources products can be divided into fractions. So coming to the properties, there are mainly four properties. So relation among decision variable must be linear in nature. A model must have an objective function. Resource constraints are essential for linear programming. So a model must have non-negativity constant. So we need to solve these non-negativity constant by using linear programming. They are the properties of linear formulation of linear program is representation of problem situation in mathematical form. So objective function is identify the converted into suitable objective function. Constants are which are available of resources surplus. So there will be no problem in making decisions. Non-negativity constitutes mean negative values of physical quantities are impossible, like producing negative number of chairs, tables. It is necessary include the element. So this is a general structure. So our aim is to maximize the profit and minimize the losses. So it is function is z. So p1 x1 plus p2 x plus up to so on pn x1 w1 the weights are assigned. So the conditions to be given and non-negative constant the xi is must be greater than or equal to 0, where I is equal 1, 2, 3 and so on, and these are the corresponding equations to the general structure of nonlinear. So we need to maximize this equation, that is Ct x. So where z is the objective function and ax less than b are the constants, c is the row vector, x is the column vector, a is an Mendelian matrix, b is carbon vector. By solving this, we can get maximum profit and minimum cost by solving the objective function. So solution procedure includes following things. First, initialization step, we introduce the stack variables. So after that, you have to perform each iteration. So the solution has to be become betterment. Determine the entering basic variable. Determine the new basic feasible solution. So after that, we conduct optimal test. Termination criteria. So if all coefficients are non-positive, this solution is optimal. So we need to come. I will share the example in the like following link. You will check how the procedure will be there. This way how the iteration process is going on by using linear programming. So I will share link. You will observe there. And next, so coming to example electrical load matching technique. So the technique load matching is find to non-geometric perspective the shortest total distance between the electric generation and electricity demand. So the cast is this problem effective area linear programming frame network. So the bounded objective function nonlinear constant to ensure that electrical demand is met at every time step. Eh, and the storage is charged and discharged in appropriate rate is out of the. So we need to minimize the cost that is f of x c transpose x and subjected to some constants that is ax equal to b. The coefficients are equation are known as cost and w is the weighting factor for each primary endogenous variable. The coefficients are usually known as should be calculated in other constants are important. So by solving this, we can maximize the profit and minimize the cost. Thank you.